まず、漢字の意味を英語で確認しましょう。いくつかの漢字は複数。使い方。使い方。一緒に見ていきましょう。まず、漢字の意味を英語で確認しましょう。いくつかの漢字は複数の意味を持ちます。訓読みはひらがなで書いています。これらの読み方は、文化庁 The Agency for Cultural Affairs じ、ず、started ふ、ぶ、不便、不便、せい、せ、よ、世界、世話する、世界、世話する、主、す、主、主、主人、主人、乗、乗る、乗せる、乗る、乗り物、乗る、乗り物、こう、降りる、下ろす、降る、降りる、降る、じ、ず、こと、家事、食事、仕事、家事、食事、仕事、今日、京、東京、京都、東京、京都。Good job. Number 2. Let's get started. し、じ、じ、世界、世話する、世界、世話する。まず、漢字の意味を英語で確認しましょう。いくつかの漢字は複数。使い方。世話する。主。使える。仕事。仕方。仕事。仕方。大。体。変わる。変える。よ。しろ。変わり。時代。変わり。時代。以下。以上。以外。以内。以下。以上。以外。以内。低。低い。低める。低まる。低い。住。住む。住まう。住所。住む。住所。住む。体。手。体。大体。体。大体。体。咲く。さ。作る。作文。作る。作文。作る。Good job! いい感じです。次は No.3。Let's get started. し。使う。大使館。使う。大使館。使う。便。便。頼り。便利。不便。便利。不便。利。聞く。便利。利用する。便利。利用する。借。借りる。 借りる。どう働く。働く。元、元、元。元気、元気。けい、今日。兄、兄。兄弟、お兄さん。兄、兄弟、お兄さん。Good job. If you feel tired, feel free to pause and come back. もし疲れたら休憩してくださいね。続いて No.4 に行きましょう。Let's get started. こう、光る、光、光る、光、光る、光。積、尺、黒、石、石。写、写す、写る。写真、写す。写真、写す。と、冬、冬。節、歳。切る、切れる。大切、親切。切って、切る。大切、親切。切って、切る。別、分かれる。特別、別。分かれる。特別、別。分かれる。よく、力、力、力。Good job. 次は No.5. Let's get started. 勉、勉強する。勉強する。どう動く。動かす。動物。動く。動物。動く。く。渋谷区。渋谷区。い。医者。医学。医者。医学。巨。子。猿。去年。去年。大。タイ。台所。台風。台所。台風。豪。が。か。合う。合わす。合わせる。都合。 会う、試合、都合、会う、試合。Way to go. 次は No.6. Let's get started. どう、同じ、同じ。み、味、味わう。意味、味、意味、味。品、品、食料品、品物、食料品、品物。員、店員、店員。門、問う、問い。トン、問題、問題。回、え、回る、回す。2回、回る、2回、回る。ず、と。わかる。地図、図書館。地図、図書館。Good job and keep it up. このペースで頑張っていきましょう。次は No.7. Let's get started. 地、地、地図、地震。地図、地震。道、食堂、食堂。場、場、会場、場所、会場、場所。せい、小、声、コア、声。バイ、売る、売れる。売る、売り場。売れる、売る。売り場、売れる。か、げ、夏、夏。席、夕、夕方、夕飯、夕方、夕飯。Good job. 次は No.8. Let's get started. や、よ、夜。今夜、夜。今夜、夜。晩、今晩。毎晩、今晩。毎晩。たい、た。太い、太る。太い、太る。太い、太る。こう、好む。すく、好き、好き。し、姉、姉。お姉さん、姉、お姉さん。まい、妹、妹。姉妹、妹、姉妹。 し、始める、始まる、始める、始まる。Good job! 残りやっていきましょう。No.9 Let's get started. じ、あざ、漢字、漢字、室、室、教室、教室、寒、寒い、寒い、奥、や、屋上、部屋、屋上、部屋、こう、く、工場、工場、し、一、京都市、市民、京都市、市民、き、帰る、返す、帰る。Now you're here. Way to go. 次は No.10 やっていきましょう。Let's get started. こう、広い、広まる、広める、広い。と、炊く、旅。一度、今度、一度、今度。県、今、建てる、立つ、建物、建てる、建物、建てる。引、引く、引ける、引く、引き出し、引く、引き出し。追う、押す、押さえる、押す、押し入れ、押す、押し入れ。弱、弱い、弱る、弱まる、弱める。弱い。今日、こう、強い、強まる、強める。シール、強い、勉強する、強い、勉強する。Good job! 次は11です。一緒にやっていきましょう。Let's get started. てい、大、で、弟、兄弟、弟、兄弟、弟。たい、待つ、待つ。しん、心、安心、心、安心、心。し、思う、思い出す、思う、思い出す、思う。ぼう、忘れる、忘れる。急、急ぐ、急に。急行、急ぐ、急に。急行、こう、急ぐ、急に。急行、急ぐ。しゅ、首、首。 すごい。次は12です。Let's get started. 悪、お、悪い、悪い、い、意味、用意する、注意する、意味、用意する、注意する、所、ところ、近所、住所、台所、近所、住所、台所、じ、持つ、お金持ち、持つ、お金持ち、持つ、今日、教える、教わる、教室、教える、教室、教える、文、門、ふみ、今日、ち、教室、作、料、料理、料理。次は13です。Let's get started. ほう、型、仕方、夕方、仕方、夕方、旅、旅、旅行、旅行、族、家族、水族館、家族、水族館、そう、さ、早い、早まる、早い、ち、遅れる、遅らす、遅い、遅れる、遅い、めい、妙、明かり、明るい、明らか、説明、明るい、明日、明日、説明、明るい、明日、明日、暗、暗い、暗い。You are awesome. 次は14です。Let's get started. えい、映る、映す、生える、映画、映画、春、春、春、中、昼、昼間、昼、昼間、昼、初、暑い、暑い、曜、曜日、曜日、ゆう、う、ある、有名、有名、服、洋服、洋服。お疲れ様でした。
Finally, before we get into the technical stuff with big O. So in this video, we will be covering the basis of LeetCode, which is space and time complexity. We will also be going through all the questions below.
Okay, in this series of tutorials, we're going to learn how to take our text-based, console-based super to-do list, where we can, print a list, make a list of items, kind of a to-do list, and task, and it appears down here. We've got 1, 2, 3, 4, 5, 6, 7, 8 buttons, which do various things, and we'll talk about that as we move on. And we have at the bottom, we have something called a list box, which is just as you would expect it to be, a list of items. And so we're going to learn how to, do things with the list box during this set of lessons. But for now, we're just going to learn how to set this up and make it look as it is. So I'm going to move that off to the side. And so TK enter. So what we want to do is we want to create the widgets. So I'm going to go all the way down to the bottom here, and because that's something we're going to do. Okay, in this series of tutorials, we're going to learn how to. Later, what we'll do is we'll learn how to start. When we're doing this, we want to think about. Move that over a little bit, and we want to think about our GUI. So what elements do we need in our GUI? So the elements will be the first thing we're going to work on. So
Your foundations as a software engineer, there's a 20-page doc.
Pretty printer. Really cool thing if you haven't seen this. So to do this, we're going to say printer. In this video, you'll be building 8 unique games using Python and Pygame. Now, not only is this going to be super fun and give you some awesome games that you can share with your friends and family, but it's going to teach you a significant amount about Python and about building larger projects in general. We've got games like entire platformer games. We're building out different physics components. We've got things like a car racing game, making the classic game of Pong, 2048. We've got checkers with AI. We've got all kinds of stuff, even like Space Invaders. And the way that I've set this up is we're going to go from the easiest project to the hardest. So we're slowly going to build our way up. And if there's one project that interests you more than others, check the video player for all of the timestamps for these different projects. With that in mind, stick with me for some important information. All of the resources that you'll need for these projects is available from the description. So if you need an image or a sound effect, you want to reference the finished code, all of that will be available from the description. It'll be titled under the project name itself. So if you're working on the platformer, for example, and you need those images, go find the platformer, and beneath that, I'm going to have all of the different resources for that project. Now, I absolutely love Pygame, and that's the module we'll be using to build out all of these games. And you'll see on my channel that I have tons of tutorials just covering Pygame. So what I did
乗る
Here is I combined some of my best videos, ordered them so they're easy to follow along with, and combined them into this video so you guys have one resource that contains really everything you need to know to get really good at Python and build some awesome projects. Now, if you appreciate this teaching style, if you want to learn more, if you want to become a software developer, I do have a program with Course Careers. Now, this is not just any other course. This actually is designed to specifically get you a job, and we walk you through everything from building your resume, applying to different companies. We have a Discord group you can join where we have coaches. Obviously, I'm in there, some other expert software engineers, and we guide you every step of the way to software development jobs for you can. I know this program out. With that said, and now, in this video, I'll give you an introduction to Python game development by walking you through creating a simple, fun, yet extensible game. We'll make this game using the Pygame module, which is a simple 2D graphics library in Python that allows you to create a variety of games. In case you're curious, I have tons of different Pygame tutorials on this channel, and a recent one I posted actually shows you how to build an entire platformer game. Here we'll make something much more simple just to get through the basics and get you up and started as fast as possible. Let me show you a demo of what we're going to build. So on the screen here, you can see our game. Again, this is fairly straightforward. We have a background, we have a rectangle that you could change to some kind of sprite or character if you wanted to, and then we have projectiles that are falling on the screen. As we progress further, these projectiles will get faster and more of them will fall, and eventually, if we are to collide with one of these rectangles, then it will tell us that we lost. Obviously, you could go and add lives, you can make different levels, you can make this game really completely your own, but I wanted to show you the basics covering things like movement, collisions, projectiles, backgrounds, and all of that kind of fundamental stuff that once you know, you can make a ton of different games with. So with that said, let's get into the video. So the first thing we need to do when we're going to be working with this Pygame module is we need to install Pygame. Now to do that, you're going to open up a command prompt or a terminal and type the following command. Command, which is pip install Pygame. Now,
maybe I was wrong and you were right, but I don't really wanna have this fight. I just wanna feel like I belong. And every time my heart swings back to you, you are my morning and
for some reason this command does not work for you, you can try to run the command pip reinstall Pygame, and if neither of those work for you, I will leave 2 videos in the description, and I'll kind of throw the thumbnails up on the screen that explain to you how to install Pygame. Alright, so now that Pygame is installed, we can start using this library. Now I've used this a ton of times, but I'm going to walk you through step by step how we set everything up. So the first thing to do is is go into a new Python file. You can see I'm in one here in VS Code. You can work in any editor that you like, and import the Pygame module. Now while we're up here, we're going to import a few other modules we're going to use for this game. So we're going to import time, and we are going to import random like that. Perfect. Alright, next thing we're going to do here is set up our Pygame window. Now, the first thing you need whenever you're working in Pygame is some kind of window. This is really the place where you can draw different objects and actually have your game running. Now, for your window, you need a width and a height. So I like to define my width and height at the top of my program in all capitals, just so that it's clear that these are constant values and they're not going to change. So for the width, I'm going to make this 1000, and for the height, I'm going to make this 800, and that is in pixels. Now, if you are working on a small display, chances are this will be too large for you, so you can make these values smaller so that the window will actually fit on your screen. Okay, now that we have the width and the height, we're going to say win, standing for our window, is equal to pygame.display.set_mode, and inside of here, we're going to pass a tuple with the width and the height. Make sure you have two sets of parentheses here, and inside of this inner set you have your width and then your height. Make sure you spell the width correctly. Okay, the next thing we can do is set a
It has its own design, and even if you never see it, baby, you're all that I need. Maybe it's the silence in your eyes, maybe it's the lilac when you're shy, maybe it's the mystery.
caption for our window. This is going to be the name at the top of the window. To do that, we can say pygame.display.set_caption, and then we're going to pass a string here, and I'll just call this something like space dodge, but you can call this whatever you want. All right, before we go any further, let's run our code here. So I'm going to go and type Python and then main.py. Whatever editor you're working in, I assume you know how to run your Python script. In VS Code, you can also press this button. Okay, so when I do that, you'll notice that a window kind of popped up and then it disappeared immediately. That's because we don't have any loop kind of running that keeps our program alive. You can see again, when I run this, window pops up and then it closes. In a minute, we'll make sure that window stays alive, and I'll show you how to do that. Perfect, so now that we have our window here, our width and our height, we need to set up what's known as the main game loop. Now, whenever you're working in Pygame, you need a loop, typically a while loop, that is going to run while the game runs, right? So that actually keeps it alive. The while loop will do things like check for collision, check for movements or key presses, and then adjust what's being displayed on the screen. So what we're going to do is create a function called main. This is really where the main game logic is going to exist. For now, we're going to create a variable called run. We're going to say this is equal to true. And we're going to say while run, and then inside of here is going to be our main game loop. So the first thing that I always do inside of my game loop is I check to see if the user pressed the X button on the window. If they did that, then I want to close the window. It's not automatically programmed in. You need to handle that key press yourself. So to do that, I'm going to say for event in pygame.event.get, and this is essentially a list that contains all of the different events that have occurred in the last, kind of iteration of this loop. Then what we do is check for the X button event. So we're going to say if event.type is equal to pygame dot, and then in all capitals quit, what we are going to do is say run is equal to false, which will then end this while loop, and we are going to break out of the for loop because there's no reason to continue checking the events if you've hit the quit button. Then at the very end of our function here, we're going to say pygame.quit, and pygame.quit will just close the Pygame window for us. All right, so very quick recap of what we've done here. We've said run is equal to true. While the variable run is equal to true, we're going to check all of the different events that are occurring. This again will give us events like key presses, mouse being moved, all that kind of stuff, as well as if we hit the button in the top right-hand corner, that X button, which is the event.type, equal to pygame.quit. If that's the case, we're going to say run equals to false. We're going to break out of this for loop, and then that will force us to have this statement here, which will quit the pygame window. Now what we need to do is call this main function so we can test this out. We're going to say if underscore underscore name is equal to underscore underscore main, like that. Then we are going to call the main function. Now what this statement is doing right here is making sure that we are directly running this Python file. So we're running the file itself, we're not importing it, because if we were to import it, or if we were to not have this line, for example, and we were to import this file from another Python file, it would start running our game, when we only want to do that if we directly run this Python file. So hopefully that makes a bit of sense, but this is just checking if you've run this file directly, whereas if you were to import it, this is going to be false. Okay, so now let's run our code. Python main.py, notice the window appears, and it has space dodge as the caption. Then if I press this X button, we can close out of it. That only works because of the code that we've written here. Fantastic. So the next thing I want to do is have a background image, and then I want to have a character that can move around on the screen. So let's start with the background image. Well, for our background image, we need some image that we're going to display on the screen. Now notice here that I actually have one, bg.jpg. Now this is a largish image, which is just a space background. All of this code will be available from my GitHub, including the image. So if you want to want to download this exact image, you can do that by going to the link in the description. If you don't want this image and you just want your own background image, then just save an image. You can call it whatever you want, but put it in the same directory as your Python script, and then I'll show you how we can use that image as a background. So at the top of our program here, we're going to say bg, standing for background, is equal to pygame.image.load, and then we are going to load the name of our file, which in my case is bg.jpg, like that. That's all you need to do to actually load this image into Pygame. Now, if you named your something else, obviously you're going to change the name to match that. And if you had it, for example, inside of a directory, then you would do something like /images/ and then bg.jpg. There's a few other ways to go about doing that, but in this case, we're just going to load directly from the same directory that this Python script is in. Okay, now that we have our background image, we actually need to put that on the screen. Now, I like to do all of my drawing in a separate function just to keep it very clear and kind of organized. So I'm going to create a function here called draw. Inside of this and kind of organized. So I'm going to create a function here called draw. Inside of this function, for now, I'm going to draw this background image onto the screen. To do that, we're going to use our window, which is this capital Win variable, and we're going to say win.blit. Now, blit is a special method that you use when you want to draw an image or a surface, that's what's referred to in Python, onto the screen. So we are going to blit the background image, and then we need to pass the coordinates of the top left-hand corner of this image. So in Pygame, when we're talking about our coordinate system, 0, 0 is the top left-hand corner of the screen. So if I run my code here, this should still be okay. Oops, that's not working. Let's do this. You can see that where my mouse is, this is 0, 0. If I go all the way over to the right here, now we are at whatever the width of the screen is, which is 1,000, and then the y coordinate of 0. If I were to go down here, now we are at the width of the screen, which is 1,000, and then the height of 800, or the height of whatever our screen is, because that's kind of how the y is incremented. So rather than y going up, the y actually goes down. 0 is the top, and as you go down to the bottom, you increase your y value. X is the same as normal, starts at 0, and as you go to the right, it increases. Meaning down here, we have an x of 0, and we have a y of the height of the screen. Okay, so that's the coordinate system. Now, I want my background image to fill the entire screen. So I'm going to put 0, 0 as the coordinate of where the top left-hand corner of this background image should be placed. Then the width and the height will fill the screen. Lastly, we need to say pygame.display.update. This is going to refresh the display, which means any draws that we've done, this is a drawing event, will actually be applied and put onto the screen. Every time you update, it takes all of the draws and applies it. If you don't have an update, then nothing's going to happen on the screen. Fantastic. So now, before we exit our while loop here, we're going to call this draw function. So now, every single frame, we're going to call the draw function, and it's going to continue to draw this on the screen. Let's go ahead and run our code. Okay, so when we run it, you can see that we get our space image appearing. Now, in my case, my space image is quite large, so it actually fills the entire screen. For some of you, your image might be a little bit smaller, and you might want to scale. Get our and apply actually be going to grow the coordinate from .jpg directory like that. Pygame.image.load, and then we are going to load the name of our file, which in my case is bg.jpg like that. That's all you need to do to actually load this image into Pygame. Now, if you named yours something else, obviously you're going to change the name to match that. And if you had it, for example, inside of a directory, then you would do something like /images/ and then b. to you can see that where my mouse is, this is 0, 0. If I go all the way over to the right here, now we are entire update. This is going to refresh the display, which means any draws that we've done, this is a drawing event, will actually be applied and put onto the screen. So every time you update, it takes all of the draws and applies it. If you don't have an update, then nothing's going to happen on the screen. Fantastic. So now, before we exit our while loop here, we're going to call this draw function. So now every single frame, we're going to call the draw function, and it's going to continue to draw this on the screen. Let's go ahead and run our code. Okay, so when we run it, you can see that we get our space image appearing. Now, in my case, my space image is quite large, so it actually fills the entire screen. For some of you, your image might be a little bit smaller, and you might want to scale it up or make it larger so that it fills the screen. Now, to scale your image, you can do the following. You can write pygame.transform, if we can spell that correctly, .scale, and then you can pass the image, which in this case is the image that we want to load, and then the size that you want to scale this image to. So in my case, I want to scale my image to be width. height, so it's going to be this. Now, when you do this type of scaling, it is not going to preserve the aspect ratio, but there is different transform functions that will allow you to look up from the documentation that let you actually scale it based on factors. You can scale by 2x, 3x, 4x, etc., rather than scaling using kind of this, width height system. Hopefully that makes a bit of sense, but this will not preserve your aspect ratio. If you use a different scale function, it will. There's one that I believe is scale 2x, which just takes the image and scales it up 2 times the size. Okay, so now this should scale our image to be the width and the height. Let's quickly test this out. And let me just select this interpreter so this will keep working now. So now you can see our image looks a little bit better. We've kind of made it the exact size of our screen rather than having it be too large and overflow the screen. Okay, so now we have our background image, and we have our main event loop, we have kind of the screen appearing. The next thing we want to do is create a character that can move around. So let's do that. So for our character, we're going to go inside of our main loop here, and we're going to say player is equal to a pygame.rectangle with a capital R, and this is just going to be rect, and then we're going to pass the X position, Y position, width, and height of our player. So before I go here, I'm going to create 2 variables. One, which is the player width, which will make equal to 40, and another, which is the player height, which will be equal. To 60. I like to declare all of my constant variables in capitals at the top of my program so I can easily change them and update all of my code by just changing one variable here. So now I'm going to go to my player, which is pygame.rectangle, and we're going to pick a starting X and a starting Y position for our character. Now remember that this is going to be the top so I can easily change them and update all of my code. Code by just changing one variable here. So now I'm going to go to my player. Which is pygame.rectangle, and we're going to pick a starting X and a starting Y position for our character. Now remember that this is going to be the top left-hand corner of where we are drawing the player. So we can pick any X coordinate we want. I'm going to pick 200, and then for the Y coordinate, we want this player to be at the bottom of the screen. So to do this dynamically, we're going to take the height of the screen, and we're going to subtract the height of the player. So we take height minus player height. That gives us the top left-hand corner where we draw this player. So that means that since our height is 800 and our player height is 60, we're going to draw this at 740, meaning the bottom of the player will be directly at the bottom of the screen. You'll see what I mean when we draw this, but that's why I'm using this math here. Next, we're going to pass the player width and the player height. So it goes X, Y, width, height whenever you're using a rectangle in Pygame. Okay, so now that we have our player, we want to draw this player onto the screen. So I'm going to pass this player rectangle to my draw function, and then I'm going to go to draw, and I'm going to accept my player rectangle. Now I'm going to draw it. To draw my rectangle, I'm going to say pygame dot draw dot rect, and then the first thing I'm going to pass is where I want to draw a rectangle. Well, I want to draw a rectangle on my window, so I pass window. The next thing I pass is the color that I want my rectangle to be. In this case, I'm going to use red. Now, in the newest version of Pygame, which most of you will be using, you can just use string colors, so red, white, black. Black, orange, any color you would know, or you can use RGB. So if I use RGB, then that would be something like 255, 0, 0, where I have 255 red, 0 blue, and 0 green. RGB, I think I read it in the wrong order. Red, green, blue, yeah, sorry. So 0 green and 0 blue, but you get the idea. You can use an RGB color code, or for simplicity, you can just write the color in, which in this case is red. Okay, next we are going to put the rectangle that we want to draw, and that rectangle is our player. So our player is a Pygame rectangle, which is an accepted argument to this method here. So we say we're drawing it on the window, it's a red rectangle, and this is actually the coordinates of the rectangle, right? So it's at 200, it's at this height, and it has this width and this height. Perfect. Now that we have that, we should see a red rectangle appearing when we run our code. There you go, we have our rectangle showing up on the screen. Fantastic. Now that we have our rectangle, we want to move it around. Now, Now, to move the rectangle is as easy as adjusting the x coordinate of this rectangle. So let's have a look at how we do that. The first thing we need to do is listen for different key presses. So if the user presses the left arrow key, I want to move to the left, which would be reducing its x value. If they press the right arrow key, I want to move to the right. So I'm going to say keys is equal to pygame.key.get_pressed. Now this will give you a list of all of the keys that the user has pressed and tell you, well, if they press them or not. So what I can do here is say the following. I can say if keys, and sorry, I said list, I mean dictionary, and then I can say pygame.k_left, which is the code for the left arrow key. If that's the case, then I can take my player pressed or pressed. Now this will give you a list of all of the keys that the user has pressed and tell you, well, if they press them or not. So what I can do here is say the following. I can say if keys, and sorry, I said list, I mean dictionary, and then I can say pygame.k underscore left, which is the code for the left arrow key. If that's the case, then I can take my player.x and I can subtract from that the player velocity, which is a variable that we're going to define now at the top of our program. So we're going to say player what? Velocity, which is a variable that we're going to define now at the top of our program. So we're going to say player what? Player vel, sorry. Is equal to 5. Let me just move this down. Okay, so we're saying if keys pygame.k underscore left. You may be wondering how I found this. I just know it because I've used it many, many times before, but this is the kind of, what do you call it? It's code for the left arrow key. If you wanted, for example, the A key, then it would be K underscore A or K underscore B or C, etc. If you wanted like the shift key, it's K underscore shift. There's a whole kind of documentation where you can look up all of the key codes from the Pygame website. You can also just look up Pygame key codes and you'll probably find a big list that tells you, but the common ones are going to be like space, shift, C, A, W, etc., or left, right, so on. Okay, so if they are pressing the left arrow key, then we're going to subtract the Y. The reason we subtract, sorry, not the Y, the X, is because we want to move them left. So by subtracting their X coordinate, we move them closer to the 0, 0 position, so to the left. That's why we're doing this subtraction. Now we have the player velocity set at 5, which means every time that you press this key, we're going to go 5 pixels backwards. You can adjust that velocity if you want the character to move faster or slower. Now, of course, we're going to do the same thing for the other arrow key, so pygame .k underscore right. And then we say, if I can get rid of that crazy autocomplete, player dot x plus equals the player velocity. And then we say, if I can get rid of that crazy autocomplete, player dot x plus equals the player velocity. One thing to note here, when I use dot x, that's simply adjusting the first value here. So we start at 200, then we go back by the velocity. velocity or forward by the velocity, right? That's how you access that. You can also access the width property and the y property as well as the height property, and that corresponds with the values up here. Okay, fantastic. So now we should be able to move our player because we have this movement code. So let's run and see if we can do that. And using my arrow keys, you can see that I can move movement code. So let's run. Run and see if we can do that. And using my arrow keys, you can see that I can move my player. However, it's moving extremely fast. Now, the reason for this is that we haven't set up a clock or kind of a timer that regulates how fast our Pygame loop is running. Now, for some of you, if you're on a slower computer, you're going to run that and be like, oh, the speed is fine, it works okay. The issue is that the speed that this while loop runs at is what determines how quickly our character is moving. If I'm holding down the key and this while loop is running really, really fast, I'm going to move fast. If it's running very slow, say you're on a slow computer, then this is going to move slow. We don't want that. We want this loop to always run at the exact same speed, so that no matter what computer you're on, it's going to run at the same pace and your character is always going to move at the same speed. To do that, we need to set up a clock object. So we're going to say clock is equal to pygame.time.C clock. Then we're going to go here, and we're going to say clock.tick, and then we're going to put 60, which is the maximum number of frames per second, or number of times that you want this while loop to be running. So you create a clock object here, and then inside of your while loop, you have clock.tick. This is essentially going to delay the while loop such that it will only run a maximum of 60 times per second. If you wanted it to run faster, obviously you would adjust this value to be whatever the fixed FPS value is that you would like. Okay, now that we have clock.tick, you'll notice that when I run my code, my character now moves a lot slower. So again, you could speed this up by increasing the velocity, and then no matter what computer you're on, it's going to be moving at a similar or the exact same speed. Okay, so we're moving, but notice here that I can actually move completely off the screen. We obviously don't want that for a game, otherwise you can just dodge by going off the screen, so we need to make it so you can't move if you're hitting the edges of the screen. To do that, we just need to come here to our conditions where we're checking if you're pressing the left arrow key and right arrow key, and add a guard clause that makes it such that you cannot move if you're going to be moving off the screen. So the way we do this is we add another condition here with and. We say if keys pygame.k_left, and we have the player.y minus the player_velocity is greater than or equal to 0. Now, the reason we're putting this here is we're saying, okay, we're about to subtract the player velocity from the x coordinate. So if when we subtract this, the player is still above 0 or greater than 0, so their x coordinate is greater than 0, then that's okay, we can subtract this. But if it's not, so if we're going to be like -1, -2, -3, etc., don't let them move. Hopefully that's clear why we're doing that, but that's why we have this code here. Now let's copy this and put the same thing here, except now we need to change this a little bit because we're adding to the velocity, or we're adding to the x coordinate, sorry. So we have player.x, apologies, plus player.vel, and then we're going to say plus player.width, and this is actually going to be less than or equal to the width of the screen. Now this one is a little bit longer because we have to account for the fact that player.x is the top left-hand corner of our player. So we need to add the velocity, kind of like we did here, but in the opposite direction because we're increasing it, not decreasing it. And we also need to account for the width. Again, this is the top left-hand corner. Then we have a width of, in this case, 40 pixels. So we need to make sure the x-coordinate plus the width plus the velocity is going to be less than the width of the screen before we allow the character to move to the right. Okay, now let's run this and see if it works. And notice when I go to the right here, I can't move any further than the very edge of the screen. And same with the left-hand side. Okay, we now have a character that is moving around. The next thing we need to do is keep track of the amount of time that has elapsed. We then need to create some projectiles that are coming down on the screen and then check for collision with those projectiles. Currently, we're about halfway done. If you're still following along at this point, congratulations. Give yourself a pat on the back. Believe it or not, most people do not make it this far. All right, so there's a few different kind of directions we can go in here in terms of what we want to write next, but I think the easiest is going to be to handle the time, so we know how much time has elapsed. To do that, we are going to create a variable here called start time. Start time is going to be equal to time.time. Time.time is going to give us the current time. So we're going to grab the current time when the game started, and then we're going to create another variable here called elapsed underscore time and make this equal to 0. Then beneath our clock.tick, we're going to say elapsed underscore time, and this is going to be equal to time.time. In terms of what we want to write next, but I think the easiest is going to be to handle the time, so we know how much time has elapsed. To do that, we are going to create a variable here called start time. Start time is going to be equal to time.time. Time.time is going to give us the current time. So we're going to grab the current time when the game started, and then we're going to create another variable here called elapsed underscore time and make this equal to 0. Then beneath our clock.tick, we're going to say elapsed underscore time, and this is going to be equal to time.time minus the start time. So we're essentially storing what time we started the while loop at. Then every time we iterate, we're getting what the current time is and subtracting that from the start time, which will give us the number of seconds that have elapsed since we started the while loop or since we started the game. Now that we have the elapsed time, we can pass that to our draw function, and we can draw the elapsed time on the screen. So we're going to go to our draw function. We're going to take elapsed underscore time as another. Parameter here, and then we're going to draw this. Now, to draw this, we actually need to use a font because we're going to have text on the screen that says time, 2 seconds, 3 seconds, etc. So what we need to do is initialize our font module, create a font object, and then use that font to render some text on the screen. So at the top of our code, we're going to say pygame.font.init. We just need to initialize the font module. Don't ask me why we need to do this. It's a requirement from Pygame, so we just do that at the top of our program. Then we're going to come down here, and we're going to say font is equal to pygame.font.sys font with this capitalization. And then we can pass any of our system fonts. In this case, I like to use Comic Sans, and the size of our font, which I will choose as 30. You can change this to be whatever you want. There's different types of fonts you can put in here, Times New Roman, Arial, etc. And then whatever the size is, I'm just going to make it 30. So again, the procedure is initialize the font module, create a font object here, and then use the font object to create some text which you can render on the screen. So to do that, I'm going to say my time underscore text inside of my draw function is equal to font.render, and then I'm going to pass the text I want to render. Now in this case, I'm going to say time, And then inside of my f string here, I'm going to say round, and then elapsed underscore time, and then I'm going to put an S here. Then I'm going to put a 1, and I'm going to put the color, which is white. Don't worry, I'll go through this slower. I know that was pretty fast. So we have render. The first thing we do is pass the string or the text that we want to render on the screen. Now I'm using an F string available in Python 3.7 and above, and this allows me to embed a variable directly inside of the string and have it rendered as a string. So I'm saying time, colon, and then I'm rounding the elapsed time to the nearest second, and I put this inside my curly braces so that I can directly use this variable in this round function. Then I put an S so that I have, 3, 4, 5, whatever seconds. Next, I put 1. 1 stands for anti-aliasing. Don't worry about this too much, but it just makes your text look a little bit better. And then you pass the color that you want this text to be. In this case, I want white. Okay, now that we have our text, we need to render this on the screen. So we're going to say win.blit, and then we're going to blit the time underscore text, and the position we're going to blit it at is 1010. So just so we have a little bit of padding from the top left-hand corner of the screen, 10 pixels X, 10 pixels Y, just moves us a little bit off the edge of the screen so it looks a little bit better. All right, now we should be rendering the time. So let's see if that works by running our code, and notice that we have our time. It is counting up, and it will keep displaying whatever the current time is. Awesome. So now that we